Okay, now that we have these additional properties, let's see how we can use them to solve new equations. Here's an example. Solve the equation for x in the domain x is between 0 and 2 pi, where the equation is sine 5x times cosine 3x minus cosine 5x times sine 3x equals 1/2. Well, first I see that I have this combination of sines and cosines. So I pull out my list of composite argument properties and I try to match the pattern that I see in the question, where I have a sine times a cosine minus a cosine times a sine. I look through my different properties and I see a sine times a cosine minus a cosine times a sine right here in that third property. So I could rewrite this expression using 5x as a and 3x as b. Whoops. So this expression on the left could be rewritten as the sine of 5x minus 3x equal to 1/2. Well, 5x minus 3x is just 2x, so sine of 2x equals 1/2. And if I'm going to solve for x, I'm going to need to take the arc sine of both sides. So 2x is equal to the arc sine of 1/2. And then we need to solve for which angle does give me a ratio of opposite over hypotenuse of 1 to 2 in radians. So 1, 2. That makes this the square root of 3, which is one of our special triangles, 30, 60, 90 in degrees, or 30 degrees here, which would be this angle, in radians, which we can convert to pi over 6. So our 2x then is equal to either pi over 6 plus 2 pi n, or the supplementary angle to pi over 6, pi minus pi over 6 plus 2 pi n. Taking that to the next step would give us 2x. If I divide this first expression by 2, I get x is equal to pi over 12 plus pi n. I'm going to divide by 2. And if I do the same thing with the pi minus pi over 6, which turns out to be 5 pi over 6 plus 2 pi n, 2x. So x then would equal 5 pi over 12 plus pi n, since we're going to divide everything by 2. So over here, back on the left, I have x equals pi over 12 plus pi n. And if I let n equal 0, I get x equals pi over 12, which is between 0 and 2 pi. If I let n equal 1, then I'm adding pi, so x becomes 13 pi over 12, which is also between 0 and 2 pi. If I add another pi, I go beyond my range, so no solution there. On the right-hand side, if I let n equal 0, then x will equal 5 pi over 12, which is an acceptable answer between 0 and 2 pi. If I let n equal 1, then my new value for x will be 17 pi over 12. again within my acceptable range or domain. If I let n equal 2, I'm adding 2 pi to a positive value, which takes me beyond my acceptable domain. So, no more answers. That tells me that my 4 solutions are pi over 12, 13 pi over 12, 5 pi over 12, and 17 pi over 12. Success!